Hi everyone, we're going to solve this quadratic equation, which is a tricky trinomial because a is not equal to 1. So a over here would be 20, b is negative 19, and c is 3. So the way we do this when a is not equal to 1 is we use the splitting the linear term method, and this way avoids any guessing and checking. What we have to do first is find the product of a and c. So a times c would be 20 times 3, which is 60. And we kind of use this as our new c. We want to find two numbers that multiply to this, but they add to our b, the negative 19. So we got to think of numbers that multiply to 60. So 1 and 60, 2 and 30, 3 and 20. We're not there yet. They don't add to 19. 4 and 15. Hey, that sounds kind of interesting, right? 4 and 15 should work. But they've got to multiply to a positive and add to a negative, which means they both got to be negative. So negative 4 and negative 15. And that tells us how to split up our linear term, the negative 19x. We're going to keep 20x squared the same. We're going to split this into negative 4x minus 15x. Either order is totally fine. It'll work either way. Trust me on that. And then we're just going to use our GCF of both halves here to factor this into two binomials. So we look at the first half, GCF would be 4x times 5x minus 1. And the second half, GCF would be 3 times negative 5x plus 1. So here's a little problem. This is the only issue that could come up here where these are not matching. They've got to match in order to make this work. Okay, so the way we have to do this is not actually factor out a 3, but make it a negative 3. We can always switch that sign pretty easily. And then that makes it 5x minus 1. Now we're in good shape. Now they match. And now we're happy because 5x minus 1 would be one of the factors, and the other factor is just the other piece there, the 4x minus 3. That's the other factor. And then that still equals 0. So this is still equal to 0. And then we use our zero product property, set each one equal to 0. Because one of them has to be 0 if their product is 0. And we just solve each one. This would be a little two-step. They're both two steps. This would be 4x equals 3 divided by 4. X is 3/4. Or plus 1 plus 1. 5x is 1. So x has to be 1/5. So those are our two options there for x. X can be 3/4. Or x can be 1/5. And that's how we use our factoring of the tricky trinomials there to figure out directly what the product of two binomials has to be, and then we just solve there from the zero product property, knowing that one of them has to be 0. They can't both be equal to 0 at the same time, since x can't be 3/4 and 1/5. It's one or the other. And that's how we do it.